We hope you enjoyed your little break. Just a small reminder, you have a small feedback form in the dockets that we have provided. We request you all to fill it. We would love to hear any feedback or suggestions that you may have for us. Now, resuming our talks about big data, I would now like to invite Kumar. He is Database Solution Architect at Ashnik and brings with him 7 years of experience of design, development and architecting enterprise level solutions. He is an active member of Postgres user group in Asia and has been working on some of the most interesting architectures that we have delivered to enterprises across Southeast Asia. Today, he is going to throw some light on how we can overcome data silos by means of data integration. Let's hear from you, Samir.
Thank you. Morning, everyone.
Morning.
So, today from my talk, I want you guys, one key takeaway that I want all of you to take away from my presentation is those important questions, those considerations that you should have in mind before you embark on your big data journey. How to choose various different tools, various different components, which will be put together to build your first big data project. So that is what you should be looking forward to, and that is what should be your one key takeaway from my presentation. My previous speaker spoke about 3 V's. I have got fourth one, which is veracity, which is actually about accuracy of data. I was just a while ago tweeting about that, my Dutch friend is live now. He's talking about big data. My friend from Ashnik, he's talking about big data. And when you're doing that, it is very easy to have a typo. That is what can mess up your data set. And the larger your data gets, the more is the amount of typos. Of course, the percentage wise, it would be lesser, but what you have to accept is that you're going to have to live with that data anomalies, that inaccuracies, and those things. It's actually something that IBM recently added after the Gartner added the 3 V's. It is something which has been added by the IBM guys, the 4th V. Now, how these 4 V's have changed the technology landscape as compared to how our traditional IT landscape is. They have introduced the new way of looking at your data, new aspects of how you would be storing your data. So your considerations for your database has changed. Now you should be thinking about a scale-out architecture. You should be thinking about how to put all that data together, how to find correlation, and how to live with those inaccuracies, how to rank those inaccuracies, how to find the right ranking for what data I can accept and what data I should filter out, how to do that. That is what they have introduced. Now, this is a typical big data landscape that would look like. You will have feeds coming from multiple different sources. Some of them would be internal, like a relational database or a NoSQL database, which is an operational store for you, or it could be your CRM solution, or it could be your OLTP solution, which is there. Some of that data could be coming from a cloud database that you have, could be Amazon's RDS, or it could be a database as a service in any of the other cloud vendor platforms. RSS feed, news feeds coming from various different sources is also a very important input. And then you will put all that together, even social media, data coming from web services, you will put all that together, it will go through multiple phases, and at the end you will end up with all that data put together in your final data store. That is what is going to be your first step, or going to be the first building block of your big data journey. Now, why you have to put all that data together, I have a very nice example of that. How many of you have been following the news about Zika in Singapore? Right? And there is a company which used that news quite immediately. How many of you have critical illness insurance plan? I have one. Critical illness is where you get paid out in lump sum if you are diagnosed with some of the listed diseases. So Tokyo Marine, they came up with a new product which is critical illness out of a mosquito bite. So if you acquire one of these 3-4 diseases like dengue, Zika, malaria, they got you covered. And they did that within like a week's time. I was at the bus stop near my house, and I saw they already have a road show going on trying to educate people about mosquito bites, what kind of diseases it can cause, and what kind of financial impact it can have on you. So they could actually, and they were doing it in the east. I live in Bedok. So they could actually find out where is the new cluster, or where was the first cluster identified. They put all that data together. They were getting probably all that data from the news feed. They did a profiling of their existing customers. How many of them are living in the Bedok area, and then how many of them already have a critical illness plan, how many of them are covered in other aspects, and they came up with a new product. That is what big data should be doing for you. And to do all of that, one thing is very, very important. That is trying to put all the data, internal and external, together. And for that, what you need is a data integration tool, data enrichment, trying to find accuracy of your data, rank your data, filter that data, have an acceptance criteria, and then put it together in the final data. So all these components are collectively the data integration components, not just the data integration tool that you would choose. It is actually all these small components is your data integration platform. It consists of your data store, it consists of the mechanism you would use to find the links between them. It would also include your actual data integration tool or the ETL tool that you would be using. Now, there are various different tools which can help you, and in each of those categories you have got a lot of different options. So for data store, you can use Postgres. Earlier Eric spoke about Postgres. Ajit also spoke about how Postgres has got NoSQL features, how it can store JSON data, how it can store as well as relational data. So it is capable of storing various different data models. And then we have also got Elastic, Couchbase, Hadoop, MongoDB, some of the NoSQL stores. Data integration, you have got a lot of options there as well. Pentaho, Logstash, it's a tool from Elastic Stack which allows you to pull data from different sources, put them all together in a single store, or use it for analytics. Foreign data wrapper from PostgreSQL Community and Enterprise DB also could be a very strong data integration tool. It can allow you to build a logical data hub. That is what Ajit was talking about earlier. You can enrich your data. For example, you want to add timestamps. You're collecting data from sensors. Customers are earlier talking about sensor data. Right? Now that sensor data is not really very meaningful if you don't have some timestamp or some other important metrics added to that, and that could be done by data enrichment. There are a lot of tools available which can do that data enrichment as well, and that is an important thing which sometimes people miss. You have to add some additional or massage your data, enrich that data with some additional fields, additional information. To handle your data accuracy, you need some kind of natural language processing or some kind of algorithmic approach so that you can actually figure out exactly what is the score of each data value coming in, and that has to be really very fast. There are libraries available in Python which can allow you to do that. There is a very good library in Python which in fact allows you to do that. R language, of course, if you are coming from data science background, R must be your favorite language. It also has got those capabilities. Now, while I was talking about all these options, it is also very important to understand what should be your consideration while you make a choice out of all these various options. What should be that question that you should ask when you're making a choice about your data store. Eric earlier emphasized that, and Ajit also talked about that Postgres is ACID compliant, and if you're looking for ACID compliant database, then relational databases are still the best. And when you're talking about a massive scale-out architecture, then Postgres makes more sense than any other proprietary vendor. But there are many other considerations as well, not just the ACID compliance. Like, what is going to be your data model? Is your data model going to be just JSON store? Or do you also need to store some geographic coordinates? Are you also going to store relational data? What is your data actually made up of? What is the best way to represent your data? And more importantly, what is the kind of queries that you're going to do? How are you going to link different entities together? Are you going to link them by some kind of linking? So a lot of NoSQL databases are not actually very good at that, at linking different entities. Whereas relational databases have been traditionally very good at linking data with foreign links or foreign key constraints. So how are you going to link your data? Are you going to link them or embed them? That is also very important. Another fact is, which I emphasized earlier, is how much is your investment in building that data store? What is your investment in building that data store? You can go by dollars per GB, and then what is the value you're going to get out of that? Okay, you got a big data store. You ended up with all that data put together. But if the value you're getting out of it is lesser than your investment, then actually it is not helping your business much, right? So that is, cost of course is a very important factor as well. When it comes to data integration, the most important aspect of that, or the consideration while choosing a data integration tool, is going to be, what are your data sources? The data integration tool should support all these, right? If you choose a data integration tool which cannot support news feeds, or which cannot support web service calls, for example, you are building a solution where you are trying to aggregate all your sales data from all different aspects. So it's like sales 360-degree, right? In that, you have got different numbers coming from different countries. They all have different currencies, and you want to convert those currencies. So there is a very good web service available. I think it's from XC, which you can use to do that conversion. Now, if that is one of your requirements, you would need a tool which actually allows you to call a web service, not just a tool which can connect to a database. You also need a tool which, you also need to consider the fact that the tool that you're choosing, it should support all those data formats that you're going to deal with. If, alright, the database where you're going to store the final data is actually a JSON store, because that is the best way to represent your data. So you choose one of those databases which represents or which can store JSON data. But what if your data integration tool cannot handle JSON data? Or if you are storing your data as large textual data, what if your tool that you are using for data integration cannot process that large chunk of textual data? So the format of data, not just the final format, but probably the format which you start with from pulling from various different sources, and the intermediary formats as well, while you're in the process of transformations, while you're in the process of enriching that data. That also matters a lot. So these are some of the options that you have that I talked about earlier: Pentaho, Logstash, and of course EDB as well. You can use Enterprise DB to connect to different sources. And like Ajit was explaining earlier, you have got some data in your HDFS cluster that could be represented as a table. So the foreign data wrapper does that mapping all by itself. You don't have to define anything for you. And that, I think, is a very powerful feature in Postgres. But of course, if you need a full-fledged data integration tool, you might have to include a data integration solution like Pentaho or Logstash in addition to Enterprise DB. One more important thing is that in some cases, going back to my architecture, in some cases, you may not just use one single database, and each of these steps might use some staging databases. So in your whole big data architecture or in your whole landscape, you may not just need Hadoop or MongoDB or just Postgres. You might actually have to work with different databases working together, different tools, trying to work together to put that data, enrich that data for you. Enrichment, like I said, what kind of fields do you want to add? Do you want to denormalize or flatten or normalize your data structure which you are getting from all these sources? Do you want to combine them together? Do you want to convert from one format to other format, like JSON to XML, XML to JSON, or relational to JSON? Do you want to do all that? Then all these questions is what that you should try to identify in the beginning. Now, some of the things which we have understood while talking to our customers who are already in their journey of big data or who had taken some big data initiatives, some of the things which can actually set you back, or some of the things which can come in way of you becoming successful with your first big data project is not choosing the right data store or not finding the right relationships between your data sets. What would happen is you will end up with data silos. Today your data silos are sitting all in different databases. Now, when you put them together, all that is going to change is all those data silos are now put together in one data store, but they're not linked. They don't have any correlation, right? So correlation linking is very, very important. Finding that link, whether you keep it a logical link, map somewhere in your algorithms, in your program, or in whatever analytics that you're going to do, or you embed that in the data structure itself, in the model itself, or you create physical links. That is completely up to you, but there has to be some correlation when you are pulling all that data from all these different sources. Otherwise, you're going to end up with a centralized set of data silos. Like Kaustubh explained earlier about optimization of data warehouse, but your big data project should aim further from there. It should try to achieve much more than what data warehouses are achieving for you today. It should try to take you or add more value than that itself. Now, how do you get started to talking big? Identify your business problem. That is very, very important. You have to know what is the business problem that you are trying to achieve or that you are trying to solve with this new big data project. That is very, very important. If you just start building a big data lake or a big data hub, it is probably not going to end very well. So identifying your business problem, identifying your goal is very, very important. That is very important. Try to overcome the data silos by the means of data integration and correlation. And of course, you should also identify the kind of queries that you are going to run. Now that you have defined your business objective or you have defined your business goal, you should also set what are the kind of queries that you are going to fire, what are the kind of correlation or aggregation that you are going to fire. That is only when you will have a proper path or a proper journey defined for your big data project. How can Ashnik help you is by providing you consultation and implementation. And our consultation, we are very, very vendor neutral, though we love Postgres. But we are very, very vendor neutral, and that is because we tie up with many different open source, enterprise open source principal companies, and we bring a very neutral perspective to the table. We help you identify what is the right solution, what is the right data store, data integration tool, which would help you in your journey. We have a team of certified experts who have rich experience on databases, data modeling, as well as analytics and data integration. Thanks a lot, everyone.
Thank you, Samir, for those valuable inputs. I'd like to invite all four of our speakers now, and we'll open the session now for any questions that you have for our speakers. We'll be very glad to address them. Any questions for our speakers?
Thanks, my name is Ganesh. Probably all know about it. Sorry for being a bit naive on this particular subject. So we came with an idea of talking big data, right? What I would really like to know, where do we draw this line of big data? So we talk about, we've been talking data generally to most of the customers in the past. Things haven't changed. We all identify. Things haven't changed. We still use similar technologies all the way down, right? The data have grown in organic ways, multifold. At the same time, processing capabilities also have grown in multifolds. So that addresses the needs of processing requirements when it comes to doing analysis. So when you're talking, Jim, we talked what you call big data. Right? Where is that line? What is big data? So what customers, most of them that I talk to, ask the same question.
There is to answer you, there is no, you cannot put a size to big data.
So if size is not the fundamental requirement,
Yes.
and then what is a big data?
So basically,
Why are we talking big
Right.
data?
So the size is not what defines a big data. What defines a big data is the volume, the velocity and variety of the data, and the system that handles all these three aspects. Basically, it's called as a big data. And that involves your business, that involves your analytics, that involves your data storage and algorithms that you know. So basically, when you look at the big data as a holistic picture, it is about integrating all the available data sources, Today, probably you are still running analytics on top of for your businesses. You are still doing some kind of BIs. You are still running some algorithms on your systems to gain some marketing insights. Yes, people are already doing that, but the problem has changed to a new scale because it's not only the internal data that matters today. There are so many external data sources available for the businesses to use, and the challenge is how you are going to integrate those external sources into your existing data silos to make most of it. For example, a stock market, and I'll give you an example of probably have heard this story. So there was a company who was actually a brokerage kind of company who was providing some kind of services for the clients, and they were using all the internal data, stock market data. That's fine, but they come up with a very interesting idea to monitor the Twitter feeds for specific companies, and from the insights that they gain from the Twitter feeds, can they predict how that particular brand or the company is going to perform. Now that is about bringing some external data source into your existing internal data feeds that you already have. That itself is a big data problem today. It's not about how much data you are using for that. It's about your internal systems plus how many external data sources, whatever available systems that you have, are you able to integrate them and get insights out of that. So when I say customer 360, it is practically impossible to include each and every data about the customer today. It's not practically possible. But the idea is whatever data sources you have, whatever customer interactions or the information that is available in public domain, as well as you host it internally within your systems, are you able to integrate that to give a more holistic picture about your customer?
So we mean to say we talk more about insights of a particular
Insights.
data
Insights.
that relates to a business intelligence.
Exactly, but not only for the data that is available within your organization, but also from external sources.
So size is not the
Size
criteria
is
of-
not what defines a big data. It's not just the parameter which defines the big data.
So neither you talk about in
Yes.
terms of SQL capability.
So nobody will talk about
Can we
just
say
yes.
SQL is the defining thing? No.
No, it's not.
I can use SQL for big data as
Exactly. So the technology doesn't define the big data. It is the nature of the problem
the
that
nature
defines.
of the problem that we are trying.
Yeah, exactly.
And just to add to that, since you mentioned it is something to get business intelligence, do not also confuse it as a more sophisticated form of business intelligence. It is much more than that. It is something which allows you to do predictions. It is something which allows you to find new business opportunities. For example, transaction logs. How many of you are from banking industry or have worked in banking industry in past?